that this is separated here is because it's going to involve, when we looked at derivatives, we kept adding in new functions that we looked at the derivatives of. So this is the same technique of substitution, only we're going to have functions that involve natural logarithms and exponential functions. These derivatives here, hopefully you remember the derivatives of these things. What's the derivative of your favorite one here, e to the x? And e to the u is then times u prime.
Hey, I've seen that before.
I
did that. Yeah, we're good. I'm done.
That's good. What about this? Maybe we could. 1 over x. What's this?
Yeah, you want to check out 1 over Facebook?
Yeah, or u prime over u. That's good. Please notice that when you're doing the derivatives, you need to have this extra part here, right? You do the derivative as though the function inside here is just the variable, but then you have to multiply by whatever that derivative of that inside function is. When you're working backwards, it doesn't matter because you've already changed that. When you do substitution, you've already changed the variable to u. So the other way you could write this is, of course, integral of 1 over x with respect to x. That is just turning around the idea that you have up here. The derivative of ln x is 1 over x, so the integral of 1 over x is, of course, ln of absolute value of x. What? Here it has to be absolute value. Here's the reason why. When you are talking about the function ln x, it looks something like this. Roughly speaking, it looks something like that. There's ln x. Okay? Y equals ln x. The slope anywhere on that is equal to 1 divided by x. Any point you pick here, okay, the slope is equal to 1 over x. The graph of 1 over x looks something like this. The problem is when you graph y equals 1 over x, there's actually the other side of it here. There's another side of it over here. So if you're working backwards and you want to make the connection, you have to connect both parts of it here. So working backwards, you need, when you're starting with this black curve here, you don't need to talk about absolute value because everywhere that the black curve is defined, the red curve is defined. But if we turn it around and go the other way, we need to have the other side of it here. Now, unfortunately, in grade 12, you don't look at f of absolute value of x. You don't do transformations where you put the absolute value inside the function. You only do absolute value of f of x. And that was one of the easiest transformations you did in grade 12. The thing with this is f of absolute value of x, whatever the function looks like, if you have some function that looks like this, if that's f of x, if you do f of absolute value of x, it just gets rid of this side of this function and duplicates a mirror image of the other side of the function because every x value before you work out what the function is now becomes positive. So the negative part, the part of the graph that was on the negative side completely disappears, and then you're going to have a mirror image of this if I was to draw it. That thing is not a function, you're right. Very good point. You want me to try and draw it again? Yeah, Mike. Good point.
Let's do straight line.
Okay, let's do straight line to make it simple. Okay? If this is f of x, if you want to draw f of absolute value of x, any x value that was negative here, before you look at the function is positive. So f of absolute value of x just, looks like that. This part has completely disappeared here. I don't want to get too far into this because in the end you're just going to end up memorizing this, that you have to have that absolute value there. Probably the best way just to remember it in simple terms is ln of x is one side only. But 1 over x is on both sides. So if you start with the black curve, which is ln x, you can say its derivative is 1 over x because it's defined. This one is defined everywhere this one is. But if you work the other way, starting with 1 over x, it's defined on both sides. So you have to have a mirror image of it because the This thing has this symmetry. Anywhere you look at 1 over x, it's going to have the thing is symmetric, right? The slope, the area underneath, everything is the same on both sides if a person wants to draw it correctly. Okay? Anything about it is symmetric, so it's going to, well, let's just get rid of the whole thing. It's going to become clear as we start to look at specifically what those things represent. For now, you're going to have to take my word for it that you need that absolute value of x, not just ln of x. And then if this is a u here, what is that going to be? Going to be any different? Ln of absolute value of u. Is there a times u prime or anything? No, because it's already dealt with.
No way, I would say.
No way, I would say. What's this one? This will be your favorite integral, I think. You hate that. You just to be different, you're going to hate that one? E to the u plus c. I hate the plus c, to be honest with you, but we're stuck with that.
I'm done with everything.
I'm done with constants. All constants are done. No, you should just you should use a different letter. Use k. For if you're Russian or something like that, they probably use k. Everything starts with k instead of c. All right. Now that you know that, now that seems easy at that point, but when you start to look at functions, you sometimes have a hard time recognizing when these other functions are going to come up, because now that I've put these right after we talked about ln x and e to the x and all that, you know that we're looking for that. It might help to rewrite this, something like this, as 1/5 outside, 1 over x dx, right? Write it separately like that. And then it's more obvious that it's going to have something to do with natural logarithms, right? Depending on whether this is 1 over x, if this was over x squared, how would that make a difference? Let me do that as an instant replay here. How would this be different? Would it involve natural logarithms if that was there? No, because you just use the power rule then. The reason that, I guess, to help yourself here, what would that be as a power? X to the -1. The power rule says you bump it up 1, right, and use the coefficient in front. You can't do that if it's -1, if it becomes x to the 0, 0x to the 0. It's just like when you had natural logarithm as the derivative of that 1 over x, all right? What's the integral of that? Ln the lines. Ln 5x the lines. Plus c. You have to put a what? A bracket around what? Oh, you mean this? No, because the constant could be anything, right? Like usually you just tack the constant on at the very end of the whole thing. You can use whatever you want as long as you say, if you use something non-traditional, you probably should say where that's a constant.
So could we draw like a little person or something?
If you say where person equals constant, I suppose you could, yeah.
We could draw the ends.
I think you can answer any other questions you're going to come up with in regards to that question. I have given you lots of questions here that probably are more than you need, but there are some that are worth doing here, such as...
Number 5, I think.
Well...
Number 6, actually.
Number 4.
6 is confusing. 5 and 6. Number 6, because I don't know.
Now that you can do this, remember before we didn't have integrals for anything except for sine and cosine and tangent? It would actually help, I wouldn't have to shout, if you guys weren't talking constantly. Okay?
I am a constant.
I realize that. We're actually going to stop this one.